Okay, so for this one, guys, what we're going to do is we're going to look at some notes. We've got our general form. Okay, it won't always be in the standard form, which is the one that we do when we complete the square. And so what I want you to know is that if a is greater than 0, then it's upward facing parabola. That would be this. Okay, so it should be a U shape. If a is less than 0, it'll be downward facing, so like that. And so you might want to take some notes on that. As far as zeros go, we have 3 different outcomes. I know there are 4 drawings, but I'll explain. We have this outcome where if you have 0 zeros, that means that there is no intersection of the x-axis, which is right here. So this is not being intersected. And so with that being said, you can clearly see that this vertex is up here and all the points are above it. And so therefore it will never cross the red line below that, and that would be when there are 0 zeros. You can have the case where the vertex itself is actually on the x-axis, which is the only point where it touches the x-axis, so then that is your only 0. And then of course you can have where the vertex is below and it's upward facing, and so clearly it's going to cross here and here. And similarly, if you do the same thing, you can have the vertex above, it's downward facing, and it crosses there and there. And so you'll have 2 zeros in both of those cases for these two. Okay, so you'll only have one at a time, obviously, if you're graphing, but these are the 2 instances where that happens. Now, to find the zeros, you do things that we've done in the past, like factoring. We can use quadratic equation, which I don't think we've done yet. And there are other ways you can guess and check technically, but I wouldn't recommend it. So let's keep going. The next thing, we have the axis of symmetry. Well, if you have it in the form ax plus, oops, not plus, ax minus h squared plus k, then this one works just as good. And if you don't, if you have it in the general form, ax squared plus bx plus c, then you can use the following. You can take b and you can take a and you can determine what x value will be, where you can determine where the vertex is for x, and then obviously figure out where y is as well by plugging that in for x, which is what the next portion says. So if we look, you have your x is negative b over 2a, that stays the same, and if you plug whatever this value you get for x into f, the function itself, you will get what y is equal to, and then when you have that, you make an ordered pair out of it. I forgot the parenthesis. And once you make that ordered pair, the x value, the y value, and then you can figure out what that would give you what vertex value is. Then the last one is simply the y-intercept. If you plug in 0 for x, and then determine what the y value for y is, you can determine the y-intercept, and that will always be 0 and then f of x, whatever value you get when you plug 0 in for x into f.